Hello everyone, welcome to InfoStream YouTube channel. So in this video, let's discuss how to convert the given epsilon NFA into NFA. So now they have given the diagram. We will be using the 4 steps to solve the problem. So they have given the epsilon NFA diagram. So the first step is to write the epsilon NFA transition table. So how to write means we will denote all the transitions table using the DO. So DO represents the transition table. Now, what are the states I will be writing here? So what are the states given in epsilon NFA diagram? Q0, Q1 and Q2. So Q0, Q1 and Q2. Now, which is the initial state? Q0 is the initial state which I will denote using the arrow mark, and the final state is Q2. That is, it is enclosed within 2 circles, so we can call it as the final state. So I will mark it as star. So in the transition table, we will mark the star to represent the final state. Now, let's write the input string here. That is, the strings which are being used to move from one state to another. That is, the transition will be done using the input strings. So here epsilon is used, so it is called as the epsilon NFA. So A, B, C and epsilon. A, B, C and epsilon. Now let's write the table values. So Q0 when the A is given as the input. Q0 when A is given as input, so it is coming to Q0 itself. Next, whether B is given as an input for Q0? No. C? No. Epsilon is given. When epsilon is given, it is moving from Q0 state to Q1. So Q1 it is moving. So B and C are not given as the inputs. So I will be writing null. Or you can call it as 5, which represents the null. Now Q1. So Q1 is using B and epsilon. So when you give B as the input, it is moving to Q1 itself. That is self loop. When you give epsilon, it is moving to Q2. Next, A and C are not used as the input string, so I will use 5. That is the null to represent there is no transition when A and C is given as input. Now Q2. So Q2 is just using C. When C is given, Q2 is having the self loop. It is not using any epsilon because this is the final state and it is not moving further. So it is not using A, B and epsilon inputs. So let's write it as 5. Now the first step is over. That is designing the epsilon NFA transition table. Now let's write the epsilon closure for the all the states in the epsilon NFA transition table. Q0, Q1, Q2. So epsilon closure of Q0, epsilon closure of Q1, epsilon closure of Q2. So what is epsilon closure means? The state from which you will be moving and up to which you can move using the epsilon. That is the maximum states that you can travel using the epsilon. Now if you see here Q0, when I give self loop as a input, it is moving to Q0. So you must include the self loops and the epsilon transition. So self loop is there, using A it is moving to Q0 itself. So you must write Q0. Next, which are the state it can traverse. So it is using epsilon to move to Q1. So you can write Q1. Using the epsilon only it is moving to Q2. So the maximum states it can travel using the epsilon and self loop. Now Q1. So Q1 is having self loop to Q1 itself, and using epsilon it can move to Q2. It can't move to Q0 because see the arrow here. It is moving further. So here also it is moving further. There is no arrow from Q1 to Q0. So epsilon will be used to move from Q1 to Q2 state itself. Now the last one is Q2. So Q2 is having only one self loop. So we will be writing Q2 itself. It is not using any epsilon to move to further states. So now we designed the epsilon closure. So the third step is to write the NFA table. Here we are converting epsilon NFA to NFA now. So we must write the NFA table. So in NFA table also we will represent it using DO only, and the inputs, that is the states, will be Q0, Q1, Q2 itself. Q0, Q1 and Q2 itself. Now what are the inputs we will be using? A, B and C. Only A, B and C, we will be not using the epsilon. So A, B and C. Now how to find the initial and final state? Some students make mistake that in epsilon NFA diagram they have given Q0 as the initial state and Q2 as the final state. They will only be the same, but it is not the case. So what you must do is you must see the epsilon closure. So Q0 is the initial state. Now where and all Q0 will be there in the epsilon closure, that state will be considered as the initial state. Here Q0 is in only one state, that is in Q0. So you will be writing Q0 as the initial state. Next, Q2 is the final state. No, so find Q2 in all the epsilon closures. Where and all Q2 will be present, that states will be final state. Q2 is here, Q2 is here, Q2 is here. So you can conclude all the three states will act as the final state. So all the three states were final state because Q2 was present in the epsilon closure of all the states. Now we must fill the values in that table. So the simple trick is whatever the values are there in the column, just copy them. For the first row, Q0, Q1, Q2, next Q1, Q2, here it will be Q2. So what you did, just copied the element which were in the column as a row for the first row. So in every problem related to epsilon NFA to NFA transition, just do like this itself. Now we want to fill for Q1. So while filling for Q1, Q1 is the state. No, see the epsilon closure of Q1. Q1 and Q2 states are there. So Q1 and Q2 states for A where they are moving, one is moving to 5 and another is moving to 5. So you will be writing 5 itself. Next for B, for Q1 state, no, so epsilon closures are Q1 and Q2. So you must see the Q1 and Q2 state also. So Q1 is moving to Q1 and Q2 is moving to 5. 5 we don't need to represent, just represent Q1. Next for C, Q1 and Q2. Q1 is moving to 5, Q2 is moving to Q2. So you just represent Q2 here. Next for Q2 states. So the epsilon closure is Q2 state itself. So for A it is 5, B it is 5 and for C it is Q2. 5, 5, Q2. 5 represents the null state. That is, there is no transition when A or B is given as the input state. Now the last step is to design the NFA diagram. So what are the states used in the NFA table? Q0, Q1 and Q2. Q0, Q1 and Q2. Now if you see here, Q0 is the initial state and all the three states will be acting as the final state. So all the state will be enclosed within two circles, which represents they are the final states. Now when you give A as the input for Q0, it is moving to Q0, Q1 and Q2. So A as the input, it will move to Q0, A as the input, it will move to Q1 and A as the input, it will move to Q2. Next, if B is the input, Q1 and Q2. From Q1, if B is the input, it is moving to Q1 and it is moving to Q2. Next, if C is the input, Q0 is moving towards Q2. Q0 is moving towards Q2 if C is the input. Now, for Q1, when A is given, no transition will happen. When Q1 is given with B as the input, it will move to Q1 itself. That is self loop for B. Next, if you give C as the input for Q1 state, it will move to Q2. So from Q1, it will move to Q2 when C is given as the input. Next, Q2 with A it will not go to anywhere. For B also it will not go to anywhere. For C it will go to Q2. That is self loop for C. Now what we did, we just used the for step. We designed the epsilon NFA transition table for the given NFA diagram. Next we wrote the epsilon closures. So using those epsilon closures only we designed the NFA table. So NFA table designing after we wrote the NFA diagram. So hope you understood the topic, how to convert the given epsilon NFA into NFA diagram. So the more video links will be given in description, you can see it there, because the more videos or the more problems you solve, you will be understanding the topic much easily. So if you have any doubt regarding this topic, please do comment below, I will clarify it. And if you liked the video, please subscribe and support us. Thank you.